So as we have seen in the previous video, the designing of this D flip-flop. Right now we are going to check, or we are going to check its simulations or functional verifications. So for that, here we are going to write their test bin. So click on simulation, go to the project, new source, check here verilog test fixture. Let's take the file name is tb_dff. Next, we have to write the test bench for D flip-flop. That's why select here the D flip-flop. Next, finish. The default template is generated for your test bench. It take that 3 inputs for register. One is output Q, that is wire, and here it is unit under test. Now very important thing is that here we have to generate the clock, because we can't do it 0 and 1 at every instant of times or after a specific durations. So that's why we initialize that D equals to, first let's take that 1 tick B0. We initialize clock is also 1 tick B0, and we are taking that initially the reset is 1. So when reset is 1, your output should be 0. So after 100 nanosecond, we are changing this. There is no need of clock because we will generate the clock using always statement here. We are making that reset is 0, and after that we are making the reset keep as it is 0. We just change here the D. So let us assume we are taking that D is 1. After, let us assume that here we change that any arbitrary delay, we are taking that 50, here we are taking that 65. Now once we are making that reset is 0, there is no need to take once again. Just here we change that D. Initially it is taken as 0, then 1, then 0, then 1, and so on. And we will check for that various time. So 1, 0, let's take that 25 nanosecond. Again it is 1 for 48 nanosecond. It is 0 for 65 nanoseconds, and so on. Now how to generate clock? So for that, we are making that clock is 1 and clock is 0. Here initially if your clock is 1, after some duration it should be 0. After some duration it is 1, then 0, then 1, then 0. That means it just look like 1 becomes 0 and 0 becomes 1. So it can be achieved by NOT gate. But we have to provide there is certain delay, and what that delay is, you can say that is 20 nanosecond. After every 20 nanosecond, the state of clock should be changed, and it will generate that clock. So here you can write the statement for that: always hash 20. That means after this delay, what my clock should be not of clock. This is as much of simple. Save as. Check your test bench file. Yes, this is test bench file of your D flip-flop. Double click on simulate behavioral model and check its output. If there is no error, we will get that the new window for waveform. Okay, so zoom to full view, and here you can check. So we are taking the clock at upper side, then reset, then D, and at last out. So check it, observe it carefully. So when there is no clock, or when there is no rising of the clock, whatever my reset or D, your Q should be previous state, and what your previous state is X. Now when there is a rising edge of the clock at 20 nanosecond, what my reset is, it observes that reset is 1, and that's why output becomes 0. Now at next rising of the clock, even if reset is 1, so output is 0. For next rising of the clock, reset goes to 0 and your input goes to output. Reset is 0, that means it will perform as one of your D flip-flop. Right now my D is 0, so that's why it add output, it reflects the same. For next rising of the clock, it is same 0, no problem. Now at 140 nanosecond to 180 nanosecond, in between this two cursor, you can find here that input is changed from 0 to 1, but my output is not changed. Why? Because only at the rising edge of the clock input goes to output. So at 140 nanosecond, what the D is? D is 1. Sorry, D is 0, and that's why the output is 0. Now at 180 nanosecond, what my D is? So at 180 nanosecond, this rising edge, the D is 1, and that's why that output is 1. And in the same one, at next rising of the clock, it is 0, so it is 0. Just before that your D is changed, but the output is changed at only rising of the clock. So for next rising of the clock, even if here the D is changed, your output is not changed. It means here the D flip-flop is work correctly. Your input goes to output only when there is a rising edge of the clock. So this is simply a simulation of your D flip-flop. You can take a snapshot, go in the file, print preview, and you can take this snapshot. So thank you for watching this video. Thank you.